Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 9th, 2025, about 2 days ago. The standout result is that a learned token produced a machine-only synonym that, when plugged into prompts, cut average sentence counts from 42.9 to 15.8 for Gemma 3.4 BIT and reduced the median in Gemini 2.5 Flash from 37 to 4. The paper is titled Neologism Learning for Controllability and Self-Verbalization, and as we'll see later, the implications for control and interpretability are significant. This paper adds trainable tokens to steer concepts, validates self-verbalizations with plugin evaluation, reports strong AxBench scores, and shows multi-token composition that lifts, likely from 0.28 to 0.66, and the combined harmonic mean from 0.39 to 0.48. Alright, the introduction set up the promise of learned tokens. Figure 1 presents a 3-part schematic that links training, interpretation, and testing in one loop. The left panel illustrates neologism learning, where a new token in a natural prompt steers outputs toward a target concept because only the token's embedding is trained. The middle panel elicits a description of that token through self-verbalization. The right panel tests that description via plugin evaluation, checking whether behavior matches the token. So Figure 1 outlined the loop from training to plugin tests. Table 1 presents the training data targets against base behavior, which establishes large gaps the new tokens must close. Long text roughly doubles in word count, while short text drops by about 700 words. Single-sentence answers shrink from about 43 sentences to a bit over 1. Like prevalence rises from 0.3 to 9%, and judge scores for flattery, refusal, and wrong answers jump sharply. Okay, Table 1 established wide gaps between base behavior and targets. Table 2 reports gap closure percentages for 4 controls: the neologism, a long verbalization, the first synonym, and the best synonym. The neologism averages 92%, with strong scores like 105% for short text and 98% for single sentence, though long text lags at 36%. Long verbalizations average 83%, while synonyms are weaker, with best synonym averaging 39% but peaking at 86% for single sentence. So Table 2 highlighted gap closures for simple controls. Table 3 reports AxBench steering on 5 tougher concepts, and the concept scores sit at about 2 across the board, which signals very strong adherence. Overall scores land around 1.8 to 1.9, comparable to training with the full concept text. The baseline without any concept drops near 0 to 0.4, showing the learned token drives the behavior. Alright, the previous figure showed strong steering on tougher concepts. Table 5 compares few-shot prompting to learned tokens for composing short, numerical, and likely. The learned tokens clearly lift likely control, raising the single concept success from about 0.28 to 0.67, which matters because likely is the hardest to trigger reliably. Composing all 3, the harmonic mean rises from about 0.39 to 0.48, and several pairs keep similar gains without inflating short unnecessarily. So the previous table focused on composition gains. Table 9 reports how training loss matters, and the preference-style DPO with APO reaches an overall increase of about 92% versus 70% for plain likelihood. Long text control improves much more with DPO at 37% compared to 4%, and used like jumps to 103% compared to 30%. Single sentence and short text are roughly tied, while likelihood edges out wrong answer at about 110% versus 103%. So, Table 9 highlighted how the preference loss improved control. Figure 2 presents the in-context learning prompt that teaches a new token named foo through examples. The template instructs the model to study several example blocks, each with a question, an accepted answer that follows the concept, and a rejected answer that violates it, which sets a clear contrast. The prompt finishes by asking the model to apply the learned meaning and future uses of the token, enabling later control with plain prompts. Alright, 2 takeaways stand out. Learned tokens give strong, low-overhead control of behaviors, and self-verbalization plus plugin evaluation reveals what those tokens mean to the model, including machine-only synonyms that transfer across models. The broader implication is modular, interpretable steering without touching core weights. That is it for the AI Research Roundup. I am Alex. Thanks for listening.